Okay. Hello, everyone. So this week we've come to our very last problem of the week, our POW week 10. And this is our problem. The title is Two Dogs. Two dogs run around a circular track 300 meters long. One dog runs at a steady rate of 15 meters per second, the other at a steady rate of 12 meters per second. Suppose they start at the same point and time. What is the least number of seconds that will elapse before they are again together at the starting point? So let's draw our circular track. It is 300 meters long along that track. Okay, now the two dogs would have a different speed, and therefore if they've got a different speed, obviously they will be able to finish one lap at various times. So maybe the first thing we want to figure out first, or show in our working, is that our calculation for the time that each of the dogs will be able to go around the circular track. So we know that speed is calculated as distance over time. And if we use that, we want to figure out what time is, because that's what it says in the question. What is the least number of seconds that will elapse before they are again together at the starting point? So if we figure out the formula for time, that is equal to distance over the speed. Okay, so with dog one, the distance would still be 300 meters, right? Because that's how long the circular track is, over the speed, which is 15 meters per second. And then dog two, we know it's still 300 meters there, running along the same circular track, which is 300 meters. And that's over, what was the speed? That was 12 meters per second. And if we calculate what's 300 divided by 15, that is going to be 20 seconds. And then the other dog, 300 divided by 12, would be 25 seconds. Okay, so now we know that time that each of the dogs will be able to do one lap of the track, of the circular track. So our question is, when would they be again together at this starting point? Okay, so one would be quicker than the other. So what we could do, we could write down a table of values. So dog one, dog two, and we could probably say that's lap one, lap two, lap three, lap four, lap five. Maybe because we only have this much space, we can stop with lap six. Okay, so with the first lap, how many seconds was the dog able to travel around it? It's 20 seconds. Lap two, so 20 plus 20, you get 40. 40 plus 20, you get 60, or you can skip count by 20 and you have 80, 100, and 120. And then the dog two, you have 25 seconds, 50 seconds, 75, 100, 125, and 150, etc., etc. So I think they picked the circular path because we know with the circle, it's never ending. Hopefully those dogs get rest. And we see here that they will be at the starting point after what, 100 seconds. Okay, So all these would be when they would be at the starting point again. So after 20 seconds, after 40 seconds, but when would be the same time that both of them would be at this starting point? And that would be when the first dog finishes 5 laps, when the second dog finishes 4 laps, when? After 100 seconds. Okay. Now you could also do that and show that in a table like this, and you'll find that it's always after 100 seconds that they will meet again at the starting point. But our question here, because what we want is just the least number, right? Then we've got our answer, which is 100. This works as your application to what you call your LCM that your Year 7 teacher might be talking to you about, to your least common multiple. Some would call it lowest common multiple, right? And you would find that the lowest common multiple of 20 and 25 would be 100. And I hope you've learned something today, a new problem-solving strategy, and congratulations to all who entered their solution. And Rocky and I don't think this dog here would be going anywhere at any time. His speed is 0 meters per second. Right. I hope you have a lovely day. You stay awesome. See you next lesson. Bye.
Come on, Rocky, let's go.